Good afternoon, everyone. Today's lecture is going to be on the digital built environment topology and the ways in which automating the asset whole life cycle is currently taking place in both industry and academia. The aims of this lesson today will be understanding both the definitions and the developments of BIM and asset management, as well as the review of the changes that have occurred within a period of a number of years. The case study examples will be examined as well, and these are examples from industry, which will also include the applications of research-based technologies to improve asset information management. So we'll also be ending on a note on the state-of-the-art technologies and also what to expect in the future development of asset management. Now I'd like to take you down a digital wormhole and talk about the ways in which lifecycle asset management has progressed and changed over the years. Yesterday's next generation technologies includes a number of digital tools such as AutoCAD design tools, RFID tags to integrate into assets to monitor their location based on GIS data, as well as optoelectronic devices such as laser scanners that were used for survey techniques by building surveyors. But we're seeing that this is changing, and today's next generation technologies will include a number of the following items: machine learning algorithms, machine vision technologies, sensor-based technologies, as well as big data analytics associated with these applications. So we're seeing a proliferation of cheap sensor-based technologies being integrated not just into the finished building itself, but also into the process of constructing those buildings. For instance, we've seen cases where sensors are being embedded onto the construction workers to better maintain and observe how those workers are using tools or whether they're at hazards and risks. We're also seeing the implementation of machine vision technologies associated with that by monitoring those construction workers via video footage or webcams that are set up on the site. And when we say machine vision technologies, what we're talking about is pattern recognition associated with images or video clips. And the technology behind that includes machine learning algorithms. Now, machine learning algorithms are what automate the processes of recognition or pattern creation, where the software itself is generating decision-making without the need of a manual input. There are 3 stages of asset management development, and we've seen that these 3 stages have occurred over a number of years. The early initial stages was the business and asset management awareness. So this is when facilities management as an industry begins to emerge. And this is where we see that a number of standards, both the UK and the regional level, are starting to develop, but also at an international level, there is more attention being paid onto the possible benefits of generating what's known as a facilities management industry. And this is tied in with the cost and efficiencies management of those assets that are existing within buildings, and the value realization that actually property, spaces, and its assets are very heavily integrated and linked with business operations and capabilities. The next stage of development was then followed by the computerization of the tools that were used to manage those business operations as well as asset maintenance and operations. And we saw that this included not just the AutoCAD design tools, but also the newly emerged CAFM tools. Now, CAFM is the computer-aided facilities management tools, but there are a host of other computer integrated or associated tools such as CMMS software. Now, the next stage of development, possibly the most recent one which we've seen emerge now, is the BIM lifecycle management. So the extension and the use of building information modeling not just at the design and construction stages, but now more so to the post-construction stages, where the focus is on the actual asset manager and the client itself. And the UK government mandate has been a great streamliner of this agenda, certainly in terms of creating better informed clients or client representatives and making better use of this type of technology for the life cycle of the entire building. Now, there is a timeline associated with this BIM and its life cycle developments, and it follows a similar pattern to what was discussed earlier. So facilities management and business awareness is initially emerging. This is then followed by the development of IT tools for management, and this is shortly followed by the CAFM and the CAD tool standardization. And in the most recent years, we've seen that there is an emergence and the use of building information modeling and management. But at the same time, we're seeing that BIM in its own right, as well as the ways in which we collaborate, has changed and transitioned a lot from its early pre-BIM era now to the ongoing post-BIM era. So where we may have started off by object-based collaboration using AutoCAD drawings, PDFs, XML, so Excel spreadsheets, that has slowly transitioned into a model-based collaboration, where design stakeholders are exchanging the linked Revit or whatever BIM authoring tool is used. The BIM models are shared between the stakeholders versus just sharing individual documentation that sits somewhere within a silo between the different disciplines. This is then transitioned into network-based collaboration, and by network-based collaboration we're obviously talking about cloud-based solutions, and in this instance probably the most notorious one will be the BIM 360 applications, where the stakeholders are now sharing model-based objects, but they're sharing them via network systems, which creates a sort of real-time communication between the stakeholders, where the changes within the models or the project itself can be monitored and assessed. Now, the post-BIM development is certainly something that academia and industry are still very much in debate about, but we're definitely going to see new ways of sharing and collaborating, and certainly the network-based solutions are going to expand. And with the use of some of the technologies that were mentioned before, such as sensor-based technologies and machine learning processes, we're definitely going to see a lot more automation within collaboration as well as content development. Now, there are a number of emerging standards that have occurred throughout the timeline. Many of these have already been discussed and shared with you on the project brief, but possibly the most notorious ones to be aware of in the recent times are the PAS 1192, which are currently in 5 parts, with the 6th part that is currently under development, as well as the ISO standard, so the 55000 standard for asset management. These are probably the most prolific and have undergone changes over the recent years. Now, there are 3 tiers to actually implementing BIM and the ways in which its associated assets can be maintained. We start off with the data level, and this is where we can see that data is being input and retrieved in the development of an as-built BIM. But this is then followed by the formation of what's known as information. So we cannot simply assume that whatever data is input into the families will necessarily form as information. That requires careful planning, categorization of those parameters, as well as analysis. So by doing analysis on the models, whether it's your structural analysis, clash detection analysis, or cost-related analysis, you can then start to form new information. And this information is tied in with the cost and time efficiencies, which will have clear outputs during the project development stages. And finally, perhaps the most important element or tier of BIM is then the formation of knowledge. And the formation of knowledge can then provide us with better cognitive aids, particularly with the asset management and maintenance stages. And knowledge is obviously then formed via analysis and the generation of information with BIM. Knowledge cannot just be useful to the client and the asset manager, but it will definitely be useful for those designers who were involved in the development of BIM models. So to give you a simple example, when a contractor is doing a clash detection, for instance, instead of relying on a standard template to perform a clash detection on a particular type of project, what they may use is previous knowledge and insights from a previous project of a similar nature and conduct the clash detection based on tolerances that they think are most feasible and suitable for that type of project. And actually, this will then in turn reduce the amount of time that they spend on resolving those clashes. But this again leads to the possibility of automating certain types of knowledge creation and decision making for designers as well as clients. Now, utilizing present performance to optimize future decision making is something that our industry has been notoriously poor at. But we're seeing that this is certainly starting to change and take new form with the introduction of BIM. So as discussed previously, with the development of as-built BIM, we introduced the data retrieval and exchange level, which can then convert into cost and time efficiencies, as well as then form into distinct outputs for the designers or the contractors or any subcontractors, which can then form cognitive aids, whether it's during the construction stages or post-construction stages for the asset manager. But in turn, what we're ultimately hoping to see is that the use of BIM and extending its life cycle to the post-construction stages can help generate a knowledge-based feedback loop. This means that where we're using BIM for asset management and we're integrating it with real-time data on how the building is performing, this can in turn be used as a knowledge-based feedback loop to better inform those designers that have been involved in the development of that project. And typically or traditionally this has been done via a post-occupancy evaluation. So this could be argued as the new change or game changer in terms of digitizing the post-occupancy evaluation and better informing those contractors, architects, any other designers on how their designs are actually performing during building operations or business operations. Now we'll go on to talk about some real-life case studies that see the use and implementation of BIM, but not only just throughout the design and construction stages. We'll talk about how these extend to asset management in particular. And you're all aware of the beautiful Parkside and Curzon buildings. In this case, Phase 1 is our Parkside building. Phase 2 was the Curzon development. Now both Phase 1 and Phase 2 were BIM projects and implemented by a number of designers. So this meant that your architects, your MEP designers, structural engineers were all in compliance with the original contract to implement the project in BIM. In this case, it was explicitly specified that with BIM, what they meant was the use of Revit or Autodesk packages, and so that meant that they actually reduced the interoperability issues, which are very frequent within the projects that are using BIM currently. What we saw that actually Phases 1 and Phases 2 themselves rendered a learning process for the contractors and the designers involved, because much of the design team remained the same in both projects. A good example of this would be the ways in which the architects saw a reduction in the number of designers required on Phase 2. In fact, they managed to halve the amount of draftsmen and designers required on Phase 2 because of the efficiency gains and their learning curve on implementation of BIM. the use of BIM was not only critical for setting out the design, but also setting up the site. And we saw that the contractors themselves have been using building information modeling to set out the site in terms of foundations, excavation work, and particularly piling the foundations. The design teams were then obviously integrating and communicating not just via the cloud-based system, but actually reviewing the designs from the cloud-based model within their design team meetings. And the cloud-based system was obviously then integrated with what was ongoing during the construction site. So any of the activities that were then monitored on the construction site were relayed onto the cloud-based system with tasks and different stakeholders associated with those activities. Access to the model could have been done via their desktop PCs, laptops. Because they were on a network-based system, they were also accessible via mobile applications, and this became very important, certainly at the site set-out stages. One example of a useful tool that was used was the Autodesk Point Layout. The Point Layout software was what enabled them to integrate real-time coordinates, so GIS data, and input that directly into the model, so that all of the works could be better and more accurately reflected in the as-built BIM. Now, on both of these projects, Phase 1 and Phase 2, they had a clear and distinct client-driven agenda, and what that agenda entailed was the operations and maintenance using BIM. And this is something that helped shape the way in which BIM was implemented, as well as some of the new innovations in the processes and technologies adopted. So the asset information currently for both Parkside and Curzon is retrievable via barcodes, which are actually physical steel plate barcodes located all across the building. And if you ever get a chance to walk through Parkside building or Curzon, just pay a little bit more attention to your surroundings, and you'll notice that these barcodes are typically located next to the door frame of any classroom. Now, what these barcodes do is that if they're scanned using a BIM 360 platform, then they directly link that person into the as-built BIM model via the cloud-based solution. Now, those barcodes are associated with the location in the model and the room itself, but it's also associated with other external databases via URL links. And these would include things like your operations and maintenance manuals or any specifications attached to those assets. Retrieval of geometric and semantic data occurred via tablets. So in this instance, just by scanning that barcode, this is the typical user interface that you would see via your BIM 360 glue or field platform. Now, the information pertaining to each and individual room or space was hosted in what's called an information totem. So in this case, you'll notice the yellow generic model or object in the center of the screen. That is effectively the information totem. And the information totem is just a simple geometry, a family, in this case something like a generic object, and it hosts in itself a number of parameters, and these are called the FM, Facilities Management Parameters. And whether they're relevant or not, if they are in that instance, they will then be populated by the different stakeholders or designers. The information totem database structure is as follows. Now, when we say database structure, what we mean is simply the types of documents and databases that are associated with that totem. So the totem itself, in terms of the cloud-based model, hosts a number of databases. That will include things such as the site photographs, generic project documentation, any embedded parameters related to those objects, the actual contractor-related snags, tasks and checklists associated with the cloud-based model. But the totem is also linked into an external database. And that external database is added as a URL link as a parameter. So when you click on a totem where you have your FM parameters, you would then also see what's called a URL link to a specified location. So in this case, that location would have been the SharePoint. And the SharePoint then hosts a number of different databases of relevant types of information, such as the maintenance frequency codes. Maintenance frequency codes are typically outlined by the SFG20 document. So the SFG20 document will have a whole host of maintenance frequency related information for different types of assets. Any existing drawings, which are in PDF format, and all of these are obviously extracted from the original Revit file, photographs, reports, and operations and maintenance related manuals. Now, it is the ambition of the university and the estates team itself to integrate other external databases into the totem. And this will include things like the building management systems, the live timetabling system, which is used to actually schedule different classrooms and modules into the spaces available, as well as the student timetabling system, which monitors student attendance, so that the asset manager is better informed on the type of occupancy related or associated with each individual room. The totem itself is actually not something completely novel. It is a digitization of client information requirements. So rather than separately putting in the information into each individual object or item or held on a separate COBie sheet, what we see is that within each model, within each room or space, the information totem hosts the client information requirements. So the assets or objects themselves have their own FM parameters, but the information totem just hosts the shared FM-related parameters, which are relevant to every single room or space within that building. Now, who fills out those parameters is something that's determined by the project documentation. For any given project that's being implemented in BIM, you would most typically see a BIM execution plan, a project execution plan, and an employer's information requirements document. In this case, we saw that the asset information matrix was used to highlight the different responsible stakeholders for each individual component or element that exists within the model, as well as the timeline or the stage at which that information needs to be populated in the model. So on the left, you'll see a sort of brief overview of the types of parameters that were associated with each individual room. So things like FM ceiling color, FM head height, FM asbestos, FM door finish, FM serial number. These are generic parameters, but they will be individually populated based on the room and the space requirements. Because each of these projects had an as-built BIM, it meant that the as-built BIM had to be validated. That validation process was done with a point cloud scan. The point cloud scanning was then used to convert or edit the BIM model. So a tolerance of 30 mil was set for both projects, and this was then used to either modify the model or make the physical changes within the construction site if necessary. Obviously, the first choice would have been more cost effective. In some cases, we did see that the actual changes were reflected in the physical construction site rather than the BIM model itself. So laser scanning is certainly an emerging technology and tool that's not just beneficial for sort of retrospective modeling or surveying, but it's also a useful tool in terms of monitoring change and progress and validating the as-built BIM model. Now, this also leads to the use of another type of technology, which is called mixed reality. And we're seeing that mixed reality solutions are something that are going to proliferate the asset management industry. If we are going to be handing over as-built BIM models, then to better make use of them with the physical world, we can start to integrate them with mixed reality solutions, where the BIM models or the components can be overlaid in the field of vision of the BIM tablet itself, when it's looking and scanning over the existing physical elements within the building. And it's a sort of similar approach to the barcode system, whereby you scan and you retrieve the data, but a mixed reality solution allows a direct overlay of the BIM data with the physical world. And because we're seeing an increased amount of software converting into a cloud-based solution, these types of tools will definitely be available via network-based collaboration. So sharing of actual real-time data will be more accessible and more useful for individual stakeholders if it is hosted on a network-based solution, where we're not relying on individual pieces of software, but we can actually share this data via cloud and network and retrieve it using mobile applications such as tablets. So what are some of the future challenges? Well, the future challenges will certainly be incorporated with these new technologies. Machine vision technologies being embedded not just on the construction site, but embedded within the asset operations and maintenance stages. Machine learning and deep learning algorithms will start to emerge with the different tools and software that are currently being used by designers and also future facilities management sector. So the BIM software development side of things is certainly going to see a number of machine learning and deep learning algorithms emerging in the near future. Sensor-based technologies, because of their cheap cost and their benefits in terms of collecting real-time data, will become more prolific, not just in the finished building itself, but certainly during the construction stages to better retrieve and understand the ongoing progress during site operations. Optoelectronic devices in this case means our laser scanning equipment, and these optoelectronic devices are certainly going to become more cheap, cost-effective, and a quicker way in terms of surveying the site as well as validating the finished product and model themselves. And possibly in the near future, we'll definitely see that the facilities management sector will start to make use of these devices more frequently than before. And the bigger challenge, and possibly the most important one, is the generation of hybrid technologies. And hybrid technologies can combine any of the following technologies that were previously discussed. So for instance, optoelectronic devices will start to integrate machine learning algorithms and machine vision to identify things like material finishes, semantic information that's attached to different objects, so for instance height and size and specification, even possible manufacturers associated with those objects. So hybrid technologies will be the amalgamation of these different types of technologies used for asset management, construction, and design. So thank you for listening into today's lecture. If you'd like to find out more about some of the following research that has been already discussed, you can do so by registering onto ResearchGate and have a look at some of the publications. The most recent publication on the information totem itself has just been published into the Journal of Automation in Construction. And if you want to follow up and read up on that, you'll find more detail about the ways in which that particular plugin was developed for Revit and how it's currently being used on a number of projects for BCU. Thank you for your time and thanks for listening in on today.